Good morning to everybody. So in this computer networks lecture series, today's topic we are going to discuss on from the unit 2, that is on flow control. Before that, I will introduce myself. I am Logesswari from RMDEC college, working as an assistant professor in CSE department. We will be discussing an important topic called as flow control. Actually, I will give you a short description of what is meant by flow control. Flow control is that flow control is one of the responsibilities. Okay, fine. Flow control is one of the responsibilities of the data link layer, as you all know. So, what is the main objective of the flow control? So, the flow control is used to coordinate the amount of data that can be sent before receiving an acknowledgement in the sense. So, it will make arrangements how much amount of that we have to send from the sender to the receiver. So what is the capability of the receiver that has to be determined. So before receiving the acknowledgement, that is the main concept of the flow control. Is one of the important functions that is responsibilities of the data link layer. It defines the set of procedures to send how much amount of it can able to transmit, and then it will wait for the acknowledgement. And the receiver has a limited speed at which it can processing an incoming data and limited amount of memory in which to store the incoming data. So the receiver must inform the sender before the limits are reached and request the transmitter to send fewer frames or to stop temporarily. So that based upon the flow control, the sender and the receiver will coordinate among themselves. It will use to reduce the congestion in the network. If there is a fast sender but the receiver is very slow, means what will happen? The data will be sent from the sender, but receiver doesn't have the capability to capture all those data. So on that time it will use a concept called as the on that time it will use the concept called as the buffer. Actually, buffer is a small amount of data. It is used to store all the data and then it will until they are processed. So whenever the receiver is very busy in doing some other work, so on that time the data will be stored in the buffer. Whenever the receiver is the receiver is free, it will go back to the buffer and get the data. Okay. So here in networks we are basically following three different types of flow control mechanism. Actually, I am going to handle this topic in 2 sessions. First, we will discuss with the stop and wait. In the next session, that is on the part 2, we will be discussing what is meant by go back NARQ. Fine. So first we go with stop and wait, and then stop and wait is a very simple protocol. Here it will wait for that means the sender will wait for the acknowledgement. Once the acknowledgement has been received from the receiver, it will send the next data. So that is the main objective of the stop and wait. Okay. Here you can see that. So here this is a sender and this is a receiver. So every time there will be a timer will be there. Every time there is a timer will be there. S is equal to 0 and then R is equal to 0. So S is equal to 0 means it will trigger the timer. Whenever we are sending the data, it will trigger the timer. If the timer expires, so within the timer expires, the frame has to reach to the receiver. So if the frame doesn't reach within the timer, means it will automatically discard that data. Okay, so that is the working concept behind the stop and wait. And the second one is that, so once I am sending the frame, once I receive the acknowledgement from the receiver, that is S is equal to 1, it will send the next frame. It will send the next frame. So before that, it will wait for the acknowledgement to get. So that is the main working concept behind the stop and wait. So the sender keeps the last frame until it receives the acknowledgement. Why? Because it will keep a copy so that you don't have to do the work one more time. Instead of that, it can do the retransmission easily. So that is the main thing. So the sender has a control variable called as sales, which will hold the number of recently sent frame 0 or 1. So if I am sending the first frame, it is 0. When I am sending the second, 1. Alternatively, we use the 0, 1, 1. So the receiver is also having the control variable, which is called as R, which holds the number of the next expected frame. The sender starts a timer when it sends a frame. If the acknowledgement is not received within the allocated time period, assumes that a frame was lost or damaged and resends it. The receiver sends the positive acknowledgement if the frame is correct. Okay, so the acknowledgement always defines the next expected frame, as you can see. So it is the acknowledgement for the 0 plus 1. It means 0 is for the acknowledgement of the first frame, plus 1 indicates that next expected frame. Okay, so in stop and wait itself we have 4 conditions. One is the lost acknowledgement. If the acknowledgement has been lost, what will happen, what it has to do. And then, so if the packet has been lost, what you have to do. So here you can see that within the timer, within the particular time, it doesn't reach to the frame. This frame doesn't reach it to the receiver. So automatically it is considered to be the frame lost. So it doesn't send, the receiver doesn't send the acknowledgement also. So the sender also waiting for the particular sort of time. So the receiver will be waiting for the frames, but the sender will be waiting for the acknowledgement. If the acknowledgement doesn't reach within the particular time, automatically it will do the retransmission. So in this way it will tackle. When the receiver receives a damaged frame, it discards it and keeps a value of it. After the timer at the sender expires, another copy of the frame 1 is sent. And the next one is lost acknowledgement. If the acknowledgement itself is lost, okay, what will happen? But the sender doesn't know. Whether the particular frame has been reached or not. It assumes that the frame is considered to be lost. So, but it is not in the real case. But it doesn't actually happen, right? So the frame has been actually received at the receiver, but it is not communicated to the sender. So again the sender will do the retransmission, because from the sender's perspective that the particular frame has not reached to the receiver, so it will go for the retransmission. But here the receiver won't receive it. Instead of that, it will discard it simply. Okay, it doesn't want to have the copy of the frame. Okay, so next one is if there's a delayed acknowledgement, what will happen? Same thing. If the acknowledgement doesn't reach within the time period, automatically it will discard it. It doesn't expect the frame, so it doesn't expect. So you can see that acknowledgement can be delayed at the receiver, or due to some problem it is received after the timer for the frame 1, but it was expired. So it will be here that acknowledgement is also discarded, as well as the frame is also discarded here. Okay, so here you can see the method called as the Bicky packing. So the Bicky packing is like just a cumulative acknowledgement. So I am sending the frame 0, acknowledgement 0, but I am sending the frame 0 plus 1. As I said earlier, 0 plus 1 in the sense acknowledgement 1. Okay, so expecting for the next expected frame. So okay, so this is about this is all about stop and wait. This is in 2 sessions. This is a continuation of this session. We will be discussing about the remaining 2 protocols. One is the selective repeat and the go back. Thank you, students.